Tommy with eMedia Press and the Energy Science and Technology Conference. Today is August 13th, 2018 at 2 o'clock Pacific time, and we have Eric Dollard on the line. And if you're on this call, most likely you have purchased his recent presentation on the history, theory, and practice of the electrical utility system, and where he goes through, I mean, it's almost a 5-hour presentation, you know, going through all the history and development of, you know, everything from light bulbs to, you know, lightning arresters and you name it, and then kind of building up to the point that different things have been done to the grid over time, which makes it even more susceptible to EMP damage and that kind of thing, which is, you know, I think a lot of people should be concerned about that. Where we're at right now is, you know, we do have some good news. The building, the balance to the building is only $3,000 something. And so with the amount of sales that have happened with this presentation already, in addition to the normal royalties that EPD Labs Incorporated is receiving for the presentation, I'm going to be able to pitch in more from the sales, and we should be able to have this building paid off by the end of next month. And so by purchasing the presentation, that's what you're contributing to, is, you know, you are getting the presentation, but a portion of the sales do go to help, you know, furthering Eric's work down there at the shop and, you know, giving him a place to write and, you know, do some experiments and stuff as, you know, as he's able to. And so, you know, we definitely appreciate your support in that. Also, Eric's official website is ericpdollard.com. That's P for his middle initial for his middle name, Paul. So ericpdollard.com. And if anybody is able to donate anything through PayPal or directly to the bank account, actually that comes to me, and then I resend the checks to the bank account down there in Nevada. In the right column of ericpdollard.com is the PayPal link, and there's also an address in Spokane where you can send any checks or money orders made out to EPD Laboratories, Inc., and then in turn I'll forward that to the account. And let's see, do you have any announcements, Eric, or anything that you want to cover first before maybe opening up for questions?
No.
Okay. Well, hopefully we don't have a big crowd on today. I know it's, you know, it's 2 o'clock right now on what is this, Monday. Most people are at work, and it's not the best time to do a conference call, but it's got to be a time that matches for me and Eric to, you know, Eric and I to be able to do this. And so I just want to let you all know that if you are able to mute out your phone, it's 4*, and if you have a question, hit 5*, and then I'll go ahead and unmute you, and then you can go ahead and you know, say your name, where you're from, and go ahead and ask your question. So go ahead and hit 5* if you have any questions. I'm going to go ahead and mute everybody out real quick. So go ahead and hit 5* if you have a question, and I'll be happy to unmute you. You're already unmuted. Go ahead and say your name and where you're from, and go ahead and ask your question.
Hi guys, this is James. Hi guys, this is James from San Francisco Bay Area. I've been a fan for a long time. Hi.
You said your name is James? James,
yeah.
Yeah, okay. Yeah, go ahead.
Cool. I'll get straight to it. My question is about Faraday tubes. About an hour and a half into the presentation, Eric starts going over this great math and all this stuff I think some of us have seen before who've been following Eric. And I've been messing with a lot of different math systems that you kind of don't find in the university space. I find them to be a little more fruitious, if you will. And so I've been messing with Eric's stuff for a little while, really studying it. And I've got basically maybe a childish question for Eric. If he could maybe explain how the Faraday tubes could be applied to different geometries rather than just the axial conductor as he presents in the presentation. I'm kind of interested in specifically the forces held by atoms between their electrons and nuclei. And then another area I'm really interested in is in the body. So utilization of ATP in the cells and the generation of same, maybe replication of DNA as well. Just some topics I've been thinking about. Thanks.
Did you get that, Eric?
Well, yeah, I mean, I can't give a whole book's worth of information in a few minutes, but the necessary information on the Faraday tubes is given by J.J. Thomson in a book called Recent Researches in Electricity and Magnetism. And then I elaborate on that in notebook number 4 of a notebook series that I don't know. I can't get any of this stuff published, so I don't know how you can get that, but I think the raw notebooks are somehow available with all the, the imperfections and what have you. And I expand on Thomson's theory pretty heavy in there and get all the dimensions worked out because these guys had their dimensions all tangled up. So I would refer you to that. So there's the first chapter in J.J. Thomson's book, Recent Researches in Electricity and Matter, gives a pretty thorough physics explanation of what Faraday tubes are and how they interact with various materials and geometries. So normally a Faraday tube in the vernacular would be called electrostatic line of force, but Thomson gets into an actual etheric description of them and their interactions, which is probably the best description you're going to find anywhere of the Faraday lines of force theory, even better than Maxwell.
Okay, thanks. I have that book. One quick question also about Faraday tubes. Do you see any application or visualization of Faraday tubes in a permanent magnet?
Well, that's how a permanent magnet gets its magnetism. There's a continuous interchange of Faraday tubes into and out of the magnetized material.
Okay, yeah, that's what I thought. You talk about
even though you have a magnet, in which the bulk of the magnetic induction is contained within the substance of the magnet, there's actually an entering and exiting flux of Faraday tubes, creating the stored energy or delivering the stored energy, however you want to look at it. It doesn't really manifest itself as energy, but as force, which is basically derived from energy. And that's why you get effects of magnetism outside of the core, like the primary and secondary windings of the transformer. It's often asked, well, how is the energy conveyed between the primary and secondary when all the magnetism is in the core? Well, what supports the magnetism is continuously entering and exiting the core.
Interesting. One more quick one about the Faraday tubes. Do you see perhaps Faraday tubes being emitted by the MWO, and somehow is that related to why it works? Maybe they contract very efficiently.
That's the whole basis of its operation, is the dielectric field that surrounds it. It's not an electromagnetic device, and it's not really involving waves. Lakhovsky really didn't have a good grasp of what was actually going on. It's predominantly electrostatic in its nature, but very complicated electrostatic structure exists around it, and of course the variations of that electrostatic structure also generate magnetism, but it's not the electromagnetic component. It's actually the longitudinal component that's doing the work.
Okay, that was a great answer. Thank you very much. That's all.
James, I do want to mention that the notebook number 4 Eric is talking about, those are available on powerofether.com. Ether spelled with an A-E-T-H-E-R. So powerofether.com, and if you look at the option number 4, it's the History, Theory, and Practice of Electrical Transmission, notebooks number 4 and 5, and that's the J.J. Thompson and Steinmetz notebook, but number 4 is part of that 2-notebook series there, which Eric was referring to. So that's, powerofether.com.
Thanks. Yeah, it's all great stuff. I've got it all.
Okay. Anybody else have any questions? Go ahead and hit 5 star, and I'll go ahead and unmute you, and you can ask your question. Okay, so let's see. If your number is ending in, actually, if your area code is 815, I'm unmuting you right now. Go ahead and say your name, where you're from, and go ahead and ask your question.
Hi, my name is Mike Huss from Wilmington, Illinois, and
hey, Mike.
One thing Eric was asking about the 2200 meter and 630 meter bands. Can I email you the information on it? You can pass. I'll give them the frequencies now, but for the information from the notify UTC and all that stuff.
Yeah, you have to mail it to me regular. I don't have any computers.
Do you want to write down the bands though, real quick? And I do have a question.
I can write down the frequencies. Yeah.
Okay, 2200 meter band is 135.7 to 137.8 kilohertz.
Okay.
And 630 meters is 472 to 479 kilohertz.
Okay, that's the maritime band.
And people are making huge loading coils and stuff to get on there. But in the presentation, you mentioned you're really irritated about them tying the neutrals together, and I actually never noticed it. I've been in several substations, like when I go on a day in the field, and you said when they do that, it creates like I don't know if you'd call it like a feedback loop, but you said that it has to go through, how did you explain it? It goes through the ground or something? It finds its way back, but it has to go through everything else to do it, or through the earth to do it?
Yeah. Yeah, this is completely jammed out. A lot of my ELF receptions, there's so much stray current flowing in the ground now that in this particular location with one element, 1,200 feet of distance between 2 ground terminals, the interference is 10 million times stronger than the signal.
Holy cow. I actually have a VLF.
I can actually get a reading on my Simpson analog volt ohm meter just between 2 ground rods spaced 1,200 feet apart in rather poor conductivity soil. There's a total impedance of about 500 ohms involved in that. And it's coming out of this hideous practice of double Y connecting the transformers and then tying the neutrals together. So the zero sequence component of the entire transmission system infects the distribution system and tries to find its way back through the earth. It also really messes up the relaying when you're trying to clear ground faults off the line. It makes it next to impossible. And basically this particular configuration of double Y and common neutrals and multiple grounds was actually prohibited in the original textbooks. You won't even find, in Steinmetz's book, you won't even find a Y-Y connection, because what it does, particularly with the common neutrals, it separates the polyphase power system into 3 independent single-phase power systems, which at the third harmonic all become in phase. So you can end up with a neutral current in a balanced configuration that's actually greater than the line current. And this is starting to happen now. Stray currents are flowing everywhere. And any transients on the high voltage neutral get into the low voltage neutral, and then that gets into the customer's neutral. So people are getting serious shocks, and livestock are being tormented by the the gradients in the ground around various substations and transformer connections. The whole thing's completely out of control. It's insane.
So, like, for example, say, and this is stations near me. We have a station, 149 TSS 149 Wilmington, and it's 138 kV coming in, 12 kV, or 34 kV and 12 kV going out. But so say there's 34 kV going out for miles, and it comes to a DC, a distribution center near me that goes from 34 to 12, and then the feeder comes out to the customer service transformers. So that if the neutrals were tied together there, it would go through the earth from that DC all the way to that TSS.
Right. Well, not only that, but it radiates out to other neutrals in other powers, other feeders. So it can, not only will it follow longitudinally back to the feeding substation, but it'll also try to find its way to the grounded neutrals in the other substation. And like I said, no transformer connection should ever be YY. It's been customary to connect the secondaries Y so that you can establish a reference potential to Earth, even though it did not originally start off like that. But the primary side of any polyphase transformer configuration should always be a delta if the secondary is Y. And conversely, if the primary isn't Y, then the secondary has to be delta. Otherwise, all the generated harmonics transmit themselves out into the power system. And they do it on a zero sequence level, so it's no longer, the electromagnetic boundary condition is defied, so ultimately what you've done is created an absolutely enormous VLF antenna. And because of the law of reciprocity, if it can blast out, that means that something can also blast in, which makes it particularly susceptible to any induced lightning surges or any type of nuclear type of phenomena or massive earth current inducements from coronal mass ejections hitting the Earth. That's particularly damaging because it saturates the cores on all the transformers. Then they can't generate an EMF, and then it short circuits the system.
Holy cow. I didn't know it was that bad. I mean, I asked one of the shift managers at work, and he came from testing group, which is a group where that's what they call a group, but they go out and set up the relaying, the time curves for the breakers and all that stuff. And I asked him, so he's very knowledgeable in all this, and I asked him, what's YY, because on SCADA, it doesn't show you what the connections are, it just, shows you in and out. And transmission lines are just a one white line, you know what I mean? You can see the amps on each phase and everything. But I asked them what's YY and what's delta Y and what's delta delta. But I guess the 34 to 12 is YY, I think, and like 12 to 4 there's some DCs that's all YY. But I think the transmission stuff is delta delta, I want to say, because there's no neutral on them. We have like static wires that are above it to take lightning strikes, and sometimes they'll energize the static wires to 12 kV to feed something like aux power or something like that. But I guess they do the VLF.
Well, normally in a transmission system, the proper way to do it is the sending end is Y connected to establish an Earth potential reference in the system. That opens up the susceptibility to core saturation, but as long as there's not a metallic path from another Y-connected system, like at the receiving end, that's not a problem. At the receiving end, the high side is supposed to be delta. One of the reasons why they're going the Y, because half-wave or two-pole transformer requires much greater insulation than a quarter-wave or a one-pole transformer. So it cheapens the cost of the transformer and tends to make it smaller, but then it introduces all kinds of complications. And there's something else going on that's superseding cost savings, because a lot of these, something or someone, some agency is dictating this complete retrograde Y connection of the entire distribution system. It's costing the power companies a fortune, and it's really bad for the customer. And the problem for me is the hideous interference it causes with reception out of the ground. You can take a take a public utility like the City of Los Angeles Water and Power, that's all delta throughout, even though the National Electrical Code is forcing them to provide Y connection to all their wells, which they don't want to do. It's traditionally been a delta-connected system since its inception in 1912, so there's some kind of nefarious government effort involved with this stuff, some bureaucrat that's got a crazy idea, and he's going to enforce it on the world. But otherwise, there's no neutral-to-neutral path anywhere in their system, nor is there any grounded neutral anywhere in the system. It's all floating delta the whole way. I can take my ELF receiver and turn it on within sight of the 4,800-volt distribution lines and have absolutely no power line interference whatsoever. I can go to another location where they ground the neutrals on the secondary side on a 12-470 system, and even though the voltage has gone up and you would expect a little more interference, the amount of interference just by grounding that neutral and Y connecting the sending end causes a 60 dB increase in interference. That's 1 million times stronger.
I understand what you mean, because I have a VLF receiver I got from Steve McGreevy, actually. I bought like 3 of them. You know him.
Yeah, he made a special unit for my car.
Yeah, I have it in the backyard, and I run DC power out to it, and have an isolating transformer. And I mean, even walking with one, and I'm on 1.3 acres, and it's only 4 kV out front. It's one phase, so 2,400 volts phase to ground. And just walking on the grass, the power line noise is so freaking loud. It blows your ears out. I can't hardly hear any whistlers, tweaks, or anything, but I can with digital signal processing. That's the only way to do it for me.
Yeah.
I want to set up an ELF station. I'm on real sandy ground out here, so what you're saying about 2 ground rods is interesting. But so say you put in 2 ground rods, I don't know how far apart for ELF. Don't you pick up anything on the conductors from that to the receiver, though? Or what do you use for conductors?
Field telephone wire, because it's cheap.
So just a single conductor.
So actually, it tends, as the frequencies get higher, it tends to operate as a beverage antenna, which wants to operate on lousy soil because it wants refraction, not conduction. But you'd have to have a wire about 50 or 60 miles long to be able to operate in that mode. Otherwise, it's just simply a ground rod differential, which then immediately opens you up to any of these stray harmonic currents that are flowing in the earth.
Gotcha. Yeah, I'm familiar with beverage antennas, like a little long wire with a 50 ohm resistor between that and ground.
Yeah, it's supposed to be actually 300 ohm resistor.
Oh.
So usually the resistance of the ground rod provides the necessary terminating resistance. But that is an electromagnetic antenna. In order to have an electromagnetic antenna at wavelengths that are 50 miles long, you have to have several miles of wire. So these are the things that I'm trying to assemble out in the desert out of abandoned long-distance telephone lines and this particular TV lines. And it was horrifying here to find out that the first test produced a 70 dB jamming over the 0 dB signal reference. And this particular utility company, NV Energy, is absolutely hideous. They've declared that they're going to eliminate every single delta connection in the entire system. They will not give me 240-volt delta power, even though I'm being metered for it and I'm paying for it. They won't put the third transformer in. They want me to rip everything out and go to 208, which is insane. Or they'll give me 277, 480, which I don't want, because then I got to have transformers. So one way or another, I got to provide my own isolation transformers, even though they they charge me for the transformers they put on the pole. For them of why this was happening, and they've absolutely refused to provide any explanation. I doubt if any of these utility companies have real engineers anymore anyway. They're all just basically software jockey, electronics techs, and I think that's part of what's going on. There needs to be some kind of committee to to actually fully investigate this and find out what in the hell's going on here. It's insane. It's absolutely insane.
I know they have some really intelligent people.
If you probably saw from my presentation, the harmonic currents have reached fault current proportions.
Oh, holy cow!
And this stuff is being delivered right to the customer. So, if I ever had the funding to do the research and whatever, I could come up with a quantitative analysis of the whole thing, including instability factors and the frequency and all kinds of stuff. But in today's society, there's no interest in any of that stuff at all. There's only interest in entertainment.
Well, I'm probably going to look at some station prints and see if our stuff was wound how you said it was, or wired how you explained it was, because I wrote everything down. So, been following your work for years. Huge fan. You're light years ahead of my understanding. You're absolutely fascinating. So, thank you so much for your time. What's the zero sequence thing that you mentioned? I don't understand that.
That's if you have an imbalance in a 4-wire system. Well, let's say you just take a 3-wire system where you got 2 hots and a neutral.
Okay, yeah, like split
and
phase.
You have an imbalance in the system, and that causes a current in the neutral.
Yeah.
That current is called the zero sequence current.
Oh, okay. Now
so
there are times where
if you have 3 phases in a neutral, you have 3 modes of propagation. One is positive sequence. That's the one that you want. That's the one that makes the motors turn forward.
Mm-hmm.
You can also have a negative sequence due to an imbalance, and that would cause the motors to turn backwards. And what it does is it gets into the motors and fights and causes them to overheat. Then you have a zero sequence where you have like 1 phase to neutral, and then that's a zero sequence current.
Gotcha.
So
the only time I've heard of customers getting shocked is if they lose, like the service wire pulled the house, 2 hots and a neutral. If the neutral connection they lose the neutral, bad connection or a cable fault, then, because normally the neutral's grounded to the ground in the panel, but then people get shocked off of stinks and stuff like that.
You won't get shocked in a situation because everything.
But you lose the neutral to the system.
But let me finish, because everything is equally hot. So everything's tied together. There is no real ground. Grounds are just resistances. There is no such thing as ground. If everything's equally hot, then it's difficult to get shocked. But let's take a situation like I had at my research facility in the Mojave Desert. So it was a hideous, multiple grounded YY, and I had an extensive ground system there. This was a massive installation. It was about 10 acres of antennas. I had 5 acres of nothing but ground rods, spaced about 30 feet apart, to establish station ground. Now, I had to have an isolation transformer to get the terminal facility separated from the power company because of this neutral interference getting into the system and creating all this harmonic current flowing in all the coax shields. Well, one day I got between the ground on the power company side and the ground on the signal side and got belted. And the same thing happened. I have a friend here who's a retired lineman and electrician who works with us on projects, and he installed the 277 480Y in the supermarket and was led to believe, like most people, that the neutral has no voltage on it, and he got in between the neutral and the water ground or something and received a very serious shock.
So can you, it's rarely that panels really never balance perfectly unless, I guess, if the only thing on it is a motor. But they say if everything's balanced, then you shouldn't get shocked off the neutral. Is that accurate?
Yeah, if there's no current in the neutral. In other words, if it's delta connected or parallel connected, if it's 220 with no neutral, then there's no potential difference.
Gotcha. I have a lot to learn still, so
So if you have, let's say you have, 300 feet of wire or whatever, 3 wires that goes out to a shack to run the outlets, well, the neutral of that is grounded at one end, but if there's an imbalance, a major imbalance at the other end, like one phase shorts the neutral, and you're between that neutral conductor and ground, you'll receive a very serious shock.
Oh yeah, anything that's not. I guess the way I was taught.
So what happens is when you have a 3-phase system, is all harmonics that are multiples of 3 all rotate in phase. So if you have 1/3 of an amp of harmonic current flowing in each of the phase conductors, and they're equal, you do not end up with 0 amps in the neutral, but you end up with 1 amp, 3 times the current in the phases. And what's happening is actually neutral conductors are starting to fry in the more modern electrical installations. And these currents are existing in all the distribution lines. And the bad practice of not running the neutral right up there with the hot conductors increases the inductance and the reactance, which makes its impedance high. And the bad practice of using a smaller neutral conductor instead of a full-size one increases the resistance. So what ends up happening is you no longer get a sine wave at the receiving end, but you get a chopped wave. And I had somebody where they drove across the United States and they took samples, and I showed that in my presentation that you don't get a sine wave anymore.
I haven't put a scope on mine, to be honest with you.
So the way the system's being operated now, you have to use 6 wires in a Star David configuration in order to properly transmit this particular YY, because a YY connection with bonded neutrals is no longer 3-phase. It's 3 independent single-phase systems, and because the harmonics, water outside the building, get rotated in phase, then you can end up with a rather serious zero-sequence current that can burn up conductors or produce enough back EMF in the conductors that somebody at the receiving end can get shocked.
Wow.
So until I have a laboratory here, which I doubt if it'll ever happen in my lifetime, but if I did, one of the reasons I chose this building is I have a 15,000-gallon and 35,000-gallon pair of tanks filled with water outside the building, which gives me an independent ground, and then I can put a current transformer on a lead that connects to that, to the power line neutral that connects to the high side. Transformers are bypassed here like everywhere else, and then actually measure what's going on, what kind of transients I get. Some of them be rather severe. So it's an experiment that I'm very anxious to do, but there's no resources for it. So maybe somebody else.
Sounds interesting. I know quite frequently there's a Tesla coil group, and they send out emails. A lot of times people are giving away distribution transformers. They just say, hey, if anyone near this town in this state wants it, whoever claims it first, come and get it, or they'll sell it for $100, but they want someone to come and get it because you can't. They'd pay a fortune to ship something like that.
Yeah.
But maybe if I see something pop up on that email list near you, I can let Aaron know or something.
Well, what I need is I have to put in a delta-delta connected isolation transformer, 30 kVA, and that's usually dry-type transformers because I got to go 240, 480 on the high side, and then 120, 240 on the low side, and then just make it 240 delta. Or if I have $30,000 to pay the power company to put in the 480, then I would go the other way. I would like to get oil-filled versions of that, but those kind of really difficult to find anymore. Then
that's what they give away is the oil-filled cans.
Yeah, but it's very difficult to find an oil-filled transformer with only a 480 volt or 240 volt primary. They typically start at 2400.
Oh.
You can get them. I mean, I've seen installations of these, in all the old buildings that I used to work in San Francisco. There it was, the power was always 480 delta with no ground, and then they stepped that down to 120/208Y for the lighting, or if it was single phase, then just 120/240. The building I worked in, it was just 120/240, and you can balance your loads that way by connecting the transformers. So you can have two so-called single-phase panels running off of a three-phase power system, and if you keep those two panels balanced within themselves and between each other, then you have a balanced system, which is important when your polyphase system, you're pretty much loaded to capacity. You can't afford having any imbalances.
Gotcha. One other thing on a different note somewhat, one thing that does bother me is that it seems they no longer manufacture transmission transformers in the U.S., only in China. So if there was like a global solar flare that affected the U.S., or, we'd be really SOL, because it's going to take years to get them replaced. We don't even make them anymore here.
Well, there's nothing really made here anymore. It's just
services.
It's just cattle management is all it is. It's a livestock situation.
This is James, right?
Basically, the harmonic situation will eventually burn out the grid without any interference from China or the sun or any other such thing.
What, does China do their stuff differently?
What's that?
Does China wire their stuff differently?
No.
Oh, well, because you said it without any effect at China, so that's what I was asking.
Yeah. No, I mean, whatever. Kim Il, whatever his name is, nuclear bomb or whatever.
Oh. I don't think they have electric there most of the time anyway.
Well, but I'm talking about nuclear EMP.
No, I follow you.
Yeah. So
your name is James, right?
Communication systems going the same route. At any rate, we better get on if other people got questions.
All right. Thank you so much for your time.
Okay.
Keep up the good work.
Okay. Yeah, and if you have any questions out there, go ahead and just hit 5-star. Let's see, if your area code is 402, I'm unmuting you. Go ahead and say your name, where you're from, and go ahead and ask your question.
Hey, Eric. Francis here from Nebraska. Didn't Tesla at one time say that he didn't need transmission lines? He could just send it all through the earth?
Well, that's what he desired to do, but obviously with the gluttony for energy as it exists today, that really isn't a very good idea. But ironically, what's happening is the way that this power system is being configured, that's exactly what it's starting to do. And conceivably, at some point, there'll be so much stray harmonic energy circulating in the earth that you actually will be able to extract free energy.
Interesting. Okay. I thought like Bedini had like a one wire transmission system too for power or something. Have you ever heard of that?
Yeah, Bedini was a magician, so he did things, but you could never. There was nothing to be duplicated. It's just a magic act. He was a good magician, but it's best just to discount all that because there's no explanation. I don't even think he knew what he was doing. And go back to the originals. So there is a longitudinal conduction mode in metal conductor. I extracted that from J.J. Thomson, and then Helmholtz demonstrates that there is a condition of non-circuital current which creates longitudinal waves, and I believe that Tesla availed himself to both of those, particularly the Helmholtz methodology, because he made reference to that, and he figured out a way to harness that particular waveform, which was completely different than the Heaviside configuration that we presently use.
Is there no surge protector I can install that would protect me from whatever, an event.
You have to have an isolation. You have to have an isolation transformer.
What is that? And is it something the average man can afford or install himself?
It costs about as much as a car. So.
Can I build one?
No. You need to get it all depends on what your electrical load is, but you need to get a 10 kVA transformer and take the line from the power company, tape off the neutral and anything else metallically connected. Take your power from the power company away from wherever you want to put your electrical system, like on a pole or a small out shack, outside building or something, and connect it line to line to the 240. Tape off the neutral. Don't use it. Keep it in a separate place. Use a minimum of grounding on the neutral, only that required by law, and keep it away from your house. And then bring the 120/240 from the transformer in plastic pipe into the house to your panel, and then put 4 to 8 ground rods around the periphery of your residence and bond them all together and ground the neutral to that, and you will have eliminated any way for that zero sequencer common mode wave to get into your house. The transformer is about $5,000, but sometimes you can find them surplus or whatever for about $200 or $300.
And we just can't build one of those if I start coiling wire and put oil in a can and et cetera?
No. I mean, you could, but you have to cut all your laminations, and you have to calculate your flux densities, and you've got to get that square transformer wire. And at that point, you will have invested so much of your own time and money into it, you might as well just go find one on the surplus market for $800.
Okay. Thank you very much. That's all I had for now. Appreciate it.
Okay.
Thanks, Francis. Okay, let's see. If your area code is 408, you're being unmuted. Go ahead and say your name, where you're from, and go ahead and ask your question.
Hi, this is James again from San Francisco Bay Area. Maybe another silly question. Do you get any interference there at the Earth Reception Project? Do you get any interference from cell phone frequencies, that high frequency stuff, that millimeter wave stuff? And if so, do you expect anything to change with the new 5G network?
No, that's a completely different dimension. So I'm receiving out of the ground mostly, and the wavelengths are, they're quite long from the electromagnetic standpoint. So they don't cause any kind of interference. As far as this 5G thing goes, I don't really see where it's going to be much worse than anything that already exists. So it's just basically going to change the wavelengths. I mean, I find it kind of a joke that, Chicken Little's running around screaming about smart meters, which put out a certain number of watts per square centimeter, but then they hold their device next to their face that puts out 100 times that power. So it's all part of the soup. The pagers, the silly phones, the Wi-Fi, power line harmonics, parasitic oscillations in computers, and what have you. It's just one big soup all the way across the band from top to bottom.
Okay, so you're not really looking at increased noise, just, a little more?
Well, what happens is when you get to a place, I experienced this in Seattle, where the electromagnetic flux density from all this crap has reached insane levels, that when it rains or there's fog or anything like that, and it moistens discontinuous metallic junctions like fences and rain gutters and loose connections on power lines and all that, is it intermodulates all the ultra-high frequency stuff and puts it down into the medium wave and short wave bands and jams them out. So
Oh, wow.
What will eventually happen here is this whole thing will finally jam itself out and burn itself out. That's the route that it's going. So the original Bell system that I was raised on was virtually nuclear EMP proof. The TD2 sites had gamma ray detectors and blast valves and blast doors, and within a 16th of a second, that facility was sealed tight. And only vacuum tubes were allowed at the line end of things or waveguide ends of things, which were not susceptible to damage, and they were easy to replace. The L carrier was shielded underground and had drain wires and what have you. So the original Bell system of the 1960s was EMP proof. The new AT&T 5G thing, one EMP and the entire thing is fried.
Gotcha. Wow. Yeah, it's kind of sobering thoughts. Maybe back to my other question, kind of more creative, childish stuff. Could you maybe describe what you think of the atomic geometry, the model of the atom?
That's actually outside of this subject right now.
Yeah, it really is. Okay.
Yeah.
All right, I'll have to rethink that.
Go to J.J. Thompson for that.
Oh, yeah, that's right. He's got that picture. It kind of looks like a heart.
That's Babbitt.
Yeah, it's there in the slides, yeah. All right, thank you.
Anyway, the atom is inscrutable, just like the inside of the sun. So it's best.
Oh, very interesting. Cool, thanks.
Okay. Let's see if your area code is 214. I believe that's down in Dallas. Go ahead and say your name and go ahead and ask your question.
Yes, this is Phillip Lewis in Dallas, Texas. And my question is to Eric. If the electric grid has never been made before, if you were to make a brand new electric grid, what would be your general philosophy on how to create a national grid?
Put it back together the way it used to be.
Okay, I appreciate it.
And that preferred method is in the presentation, of course. And did you get a chance to watch the whole thing yet?
I did watch some of it. It's pretty interesting. And secondly, I think Eric's interested in solar activities. Are you going to be monitoring a little bit the new Parker solar probe that's going out right now in orbit to orbit the sun?
No, I don't have access to any of that. I don't have facilities for any type of measurements at all anymore.
Yeah, they're going to be basically looking at magnetic reconstruction and things of that nature. I was just curious if you had any philosophies on that as well as magnetic reconnection with the sun.
No, I operate on a more primitive level than that.
Gotcha. Well, I appreciate your time.
Okay.
Thanks, Philip. Let's see. Michael in Illinois?
Yeah, Aaron and Eric. Eric,
Oh, sorry about that.
Hi, Aaron and Eric. Slightly off topic, but regarding the VLF and ELF reception, I have a VLF receiver. It's one of the McGreevy's, and it streams to the internet. It goes to a little FM transmitter to a receiver in the house. It streams to the internet 24/7 via, it's an electrostatic one, but I want to do two of the wire-wound loops, one going east and west, one going north and south. But I'm also interested, I have instructions for that I can do, but I'm also interested in ELF reception. And a lot of people make like a coil, wound on PVC and fill it with sand to prevent any mechanical vibrations and bury it. Do you have any ideas on that, Eric? Or ELF?
The bigger the diameter of the coil, the better. So I usually prefer to use large loops of telephone cable and then connect all the pairs in series. That way you can get 400 or 500 turns, make about a 20-foot square on 20-foot on all the sides, mounted on poles, and put two of them at right angles. That should give you pretty good reception. So As far as VLF and ELF goes, technically VLF stops at 3 kilocycles.
Mm-hmm.
And ELF is between 300 and 3,000 kilocycles if you follow a series, but unfortunately, when they created all that UHF and VHF and all those terms, they didn't think too much below 10 kilocycles. So technically, VLF is from 30 kilocycles to 3 kilocycles. Ultra low frequency is from 3 kilocycles to 300 cycles, and then ELF is from 300 cycles down to nothing. Because that terminology is all misleading and whatever, to go to the Bell system terminology, it's what's called voice frequencies. So the voice frequency band is taken to be from 200 cycles per second to about 3,700 cycles per second. And that's where most of the important activity is for receiving the Earth signals. Going down lower, then you're going to start getting even more power line interference, so you're going to have to use a 60-cycle low-pass filter and receive below 60 cycles. But the problem when you get down that low in ELF, and I have a receiver on the bench now, that prototype for receiving down seismic frequencies that go down to 1 cycle every 3 or 4 minutes, you can't possibly hear those. So what you have to do is you have to build a modulator and a double sideband modulator, and then convert the extremely low frequencies into a frequency that you can hear in order to to mentally grasp what's going on. Otherwise, you're just going to be dealing with instruments.
Well, I was going to record it and then speed it up. I think that's what a lot of people do on the ULF. Or they,
Yeah, the only problem with that is then you change your whole time frame. So the best thing to do is to take your received signal and run it into a balanced modulator and convert it into a 400-cycle tone, or whatever tone you find preferable, 400, 800, around in that range. That's what I use. I use the Pythagorean music tones, F, A, and C for my work. Gives me 3 channels. So you have to come up with a modulator that doesn't introduce a lot of drift or noise. I think I use mechanical switches, but those things are nearly impossible to find anymore that operate at those frequencies. But you have to have some way of taking your ELF, take that signal, and reverse the signal polarity back and forth with the bidirectional switch at some audio rate, amplify that with a regular audio amplifier, and then you can hear it out of the speaker. And then what you can do is you have another switch that reverses it back and forth again at the output of the audio amplifier, and then that turns it back into your baseband signal, which you can use for an oscilloscope or chart recorder or whatever. I've never been able to get down below 200 or 300 cycles with the stuff that I had, and I was in the process of developing another system that would go down even lower for receiving the Earth signals, but I lost my laboratory at that point, and I have no more means to put any of that stuff together. The amplifier I have now is for seismic sensors that I do have. And
yeah, that's something I find really interesting. I bought every video and both you guys have released.
Well, if you saw the one called Musical Seismograph, then you know exactly what I'm talking about.
Yeah, with the notes, yeah.
Yeah, so basically that's probably the most effective way to amplify extremely minuscule ELF signals that are going to be, like between 2 and 10 cycles a second. You can't hear those. And to have an amplifier that will amplify those without problems is not likely, so you have to go the super heterodyne route and create an intermediate frequency that is audible and is amplifiable, and
I see.
Work that back down to the baseband.
So when you're saying I was thinking of burying a coil. That's what a lot of people do. You were saying put it vertical and then have another one perpendicular. Is that what you're saying?
Yeah, have
how long of a coil? 20 foot?
Have a pair of 20-foot squares at right angles to each other, and use 50-pair telephone cable, if you can get it from the phone company, junk or whatever, it usually has an electrostatic shield on the outside, which is convenient. You can ground that. And then take all the conductors and hook them in series, and that gives you 100 turns, and 100 turns of wire in a 100-foot aperture. You'd have to calculate the inductance and figure out, what the EMF will be at the frequencies that you want to receive. I don't know what frequencies. There's all these Schumann frequencies and other things that people talk about. The main problem is going to be getting away from man-made interference, as is always the case with this kind of stuff. So,
receiving whistlers and stuff, the harmonics are insane. It goes up to 1 kilohertz.
They actually start at 18 kilocycles.
The harmonics?
The whistler starts at 18 kilocycles.
Oh, okay.
And it goes down. It seems to be pretty much dispersed by the time it gets down to about 200. But I pretty much, because of all the power line interference, I have to roll everything off at about 500. So 540 is the ninth harmonic, is particularly troublesome from the power lines. So I would have to get farther away or get into a situation like the LA Department of Water and Power, where their facilities don't generate any of this interference. They're probably the quietest electrical system I've ever heard, and then there wouldn't be any of these kind of problems. Being around any of those big DC power lines, those surges and those things would tend to interfere with low ELF reception. So
we don't have the
all
DC
these
stuff out here.
To get away from the interference. So if you bury the coil flat in the ground, the problem with that is it's going to be at right angles to the Earth's magnetic field lines, and you won't get any induction. It's very important that the coils be vertical.
I'm so glad I asked. So you're saying okay, I got you. So basically a big loop antenna, 2 of them.
Pair of them. Yeah.
Okay, and then one very last thing, and I'm so sorry to take up your time and everyone else's. Has anyone ever showed you these TLSDR dongles? I know you're not into computers. I'm well aware of that from listening to calls and the presentations. But it looks like a flash drive, a little USB dongle. You can get them for like $20 on Amazon, and they're originally meant for television reception in Europe. But somebody figured out how to rewrite the software, and it'll receive from 25 megahertz to 1300 megahertz all the way through. And there's several free programs you can use, and you can look at 3 megahertz of bandwidth at one time. Some of them out there do 10 megahertz at one time, so you can see all this stuff splattering all over the place. I do HF Mobile.
I had a setup like that with regular equipment. In fact, actually, I have spectrum analyzers sitting here that'll do that.
Well, it's a cheap way to do a spectrum analyzer, if you will. I was just wondering if anyone's ever showed you
but
that
I won't use any of that technology.
Okay. Well, thank you for your time.
What is that called, James? Or, Michael, what is that called?
Just look up RTL-SDR. I can tell you the names of the programs and everything. If you want, shoot me an email. Sure. I'll give you all the software. It's amazing, though. You can listen to police scanners and everything. Yeah,
it sounds interesting. If you're in the computer stuff.
Well,
that's the way to go, but I use conventional receiving equipment.
It'll demodulate everything, AMs, FM, upper, lower sideband, CW, they got everything on there. Narrowband, wideband FM, you name it, someone's did it.
Yeah, I don't have I'm not sure your email is, but if you don't mind emailing me, if you have...
I can't find it, I was looking for it. I sent you a message on Facebook, which I don't really like Facebook, but what's your email?
After what's going on with this... what I'm hearing on the news or whatever with all this censoring, I think basically everybody should pull off of Facebook and cause them to lose money.
I don't like it. It's too damn intrusive, and they profile. Aaron, can I shoot an email to that?
I just heard a story this morning of a restaurant owner that served dinner to one of the political, big shots, the vice president or somebody. And these people that run this internet pulled the plug on all of his social media just for providing dinner to one of the people that's in charge of our country. I think it's time to completely boycott that technology and pull out of it and bankrupt those people.
There's countries that jam cell phones just to prevent protests and stuff.
If you want to rely on that technology, then you will have to face the consequences that will come.
Well, that's why I'm a ham, so I don't have to rely on it. But all right, thank you guys.
All right, well, sure. Yeah, thank you. All right, Eric, if no final comments or anything, I guess we can go ahead and wrap it up, and I'll get this on YouTube here in a few days.
No more questions?
Yeah, any more questions? Last call. Go ahead and hit 5-star.
I can keep going.
Okay, let's see. Francis, go ahead and go ahead, Francis.
Yeah, can you hear me okay?
Yeah.
Yeah, go for it.
Okay. Eric, if we're ever in your neck of the woods, can we stop by your lab and chat or visit or not?
Yeah, that's assuming that I'm here. You would have to, make arrangements so I would know to be here when you were here.
Can we do that through Aaron or email, your web page?
You can write.
It's got to be regular mail. So if you write, I've got an address, and I pick up my mail about every 2 weeks, and that's usually how people interact with me.
Yeah, Francis, on Eric's website, ericpdollard.com, in the right column, if you scroll down, you'll see a general delivery address in Lone Pine, California, and that's where you can email them with your phone number and schedule and all that kind of stuff, and you can coordinate it through there.
Okay. Sounds good. That's all I had. Thank you much.
Okay.
Okay. Any other questions, anybody? Okay, from Holland, I think. Go ahead.
Yes, good evening. Thanks again, Kate. I have a question for Eric on the transformer. He claims that the magnetic flux lines are longitudinal from the first to the second winding. Did he find this out by experiment? And if it goes longitudinal, does it go faster than the speed of light? For is it instantaneous?
Yeah, it's longitudinal because the power flow is in the direction of the lines of force. And the velocity is indeterminate, but it's finite.
Okay. But basically what you're saying is you have the right-hand rule?
It's faster than light, and it is considered to be a velocity, but that velocity has not been measured experimentally because electromagnetism dominated the situation, and those particular ideas, people lost interest in that. But the person that made the determination of the velocity was Hermann von Helmholtz, famous electrical researcher in Germany in the 19th century. He was one of the prominent ones. Thomson, Helmholtz, and Heaviside were the three big guys.
Okay. And they did it with an experiment and they figured it out, or it's the same experiment you do with the 1.5 times the speed of light in one of your 80 videos from the 80s, I think, where you have this coil and then... I couldn't really get
that, but Steinmetz comes up with a way that velocity can be determined experimentally.
Yes. Okay. And also,
I think the video you're referring to in the 80s is the old Borderlands longitudinal videos?
Yes, exactly, where he also transmit at the end of the video the signal to the Earth connected to the sea. And in the beginning of the video, Eric shoots this wave through this coil, and then it reflects, and then it's like 1.5 times the speed of light, I think. Or 1.5 pi, I think. But, well, I thought maybe that's the same as speed what goes in the iron core from the transformer, because Eric says it goes longitudinal. because the energy and the flux gradients are in phase. So, or are like parallel to each other. So, can I compare it with like the SBI rule with your on the right hand? So then, if both are in parallel, the vector is 0, or maybe if I can make something from that.
Yeah, I didn't get much of that. Did you get it, Aaron?
Not too much. I apologize. But it sounds like it's in reference to some of the experiments on those longitudinal videos where you're transmitting it and then receiving it down at the beach. And I think he's, possibly seeing how that's relating to your explanation of that longitudinal component within the transformers, maybe?
Yeah, it's the same form. At any rate, people can write me at the address and then they can get a definite answer. That's the way it should be done.
So again, Eric's website is ericpdollar.com. In the right side, there's all the information. If anybody is listening to this, wants to help support EPD Laboratories, Inc., you can make a donation either through PayPal or by sending a check or money order made out to EPD Laboratories, Inc. It is a 501c3 nonprofit charitable corporation, and so any donations are tax deductible. The information with the mailing address is all in the right column of ericpdollar.com. And if you want to write a letter to Eric, he responds to almost all of them. You can write them at his Lone Pine address. And I guess until the next call, you're going to be out of touch for several weeks, Eric. So any final comments? Otherwise, we can go ahead and finish up.
No, that's it.
That's it. Okay, well, thanks for your time. Thanks, everybody, for being on the call. And next time we do something like this, we'll go ahead and just announce it out on the newsletters. And so thanks a lot, everybody. Have a good week.
Okay, bye.
Thank you.
Okay, thanks, Eric.
Thank you.
Thanks, Aaron and Eric.
Thank you. Take care, everybody.
Thank you. Bye.